Assalamualaikum and hello everyone. Today we are going to present about dual piston pump for the subject Principle of Food Engineering FST209. First, for my part, I will explain the introduction of the dual piston pump and its main component before the next presenter continues with the operating principle and application. A dual piston pump is a type of positive displacement pump that operates using two pistons working alternately. When one piston draws the fluid into the cylinder, the other piston pushes the fluid out. This alternating motion helps to reduce flow, pulsation, and produce a smoother and more continuous flow. Because of this feature, dual piston pumps are suitable for handling high viscosity fluids and are commonly used in the food and processing industry. Okay, next I will explain the main components of a dual piston pump. Okay, the main components include two piston, cylinders, inlet valve, outlet valve, crankshaft, and a motor as the power source. Let me explain the function of each component. The piston move back and forth to draw fluid into the pump and push out. For the cylinders, provide space for the piston to move during operation. And then the inlet valve allow fluid to enter the pump chamber while the outlet valve control the flow of fluid leaving the pump. And then the crankshaft convert rotary motion from the motor into reciprocating motion for the pistons. Finally, the motor supplies the energy required to operate the pump. So with this component working together, the dual piston pump can deliver smooth and controlled fluid flow. That's all for the introduction and components of the dual piston pump. Next, my group member will continue with the operating principle and application and so on of this pump.
Today I will talk about the operational principle of dual piston pump. To begin with, a dual piston pump is made of two pistons that are connected and work alternately. For example, when the first piston moves backwards, it creates a low pressure, causing the inlet valve to open and liquid will be drawn into the pump chamber. At the same time, the second piston moves forwards, creating high pressure, which open the outlet valve and push the liquids out. In the next cycle, piston 1 and piston 2 will change their roles, and this alternating motion produce a continuous and smooth flow with very little pulsation. Okay. Next, I will talk about the red sphere in the columns. These red spheres are check valves located at the inlet and outlet of each cylinder. Their function is to control the direction of the flow. When the piston creates a low pressure, the inlet check valve open and allows liquid to enter the cylinder. When high pressure is produced, the outlet check valve opens and the liquid is pushed out. These small valves are the reason the liquid can flow in only one direction, ensuring proper pumping and preventing backflow. In this slide, I will talk about the application of dual piston pumps. I will focus on three examples, starting with the food industry. In the food industry, dual piston pumps deliver a continuous and precise flow, which is essential for accurate dosing of ingredients. During food processing, this ensures consistent taste, texture, and product quality. They also help maintain food hygiene standards by reducing the risk of contamination during mixing and filling. Lastly, the smooth and steady flow produce uniform packaging and contribution to a reliable shelf life for food product. The second example is the chemical industry. In the chemical industry, the dual piston pumps ensure that the mixing ratios stay constant, which is very important for reaction control, product quality, and safety. It also prevents a sudden spike or drops in pressure because it is designed for high pressure operation and deliver a continuous steady flow. This protects sensitive reaction and ensure reliable chemical processing. For the last example, is scientific testing, especially in HPLC. So HPLC require a stable and continuous mobile phase, and the dual piston pump provide a steady pressure and flow, which prevent noise and bustling fluctuation in chromatograms. This is especially important for reactive index or RI detection, because even a small flow change can affect the RI signal. With a dual piston pump, the RI number remains stable, ensuring accurate and reliable analysis.
Now we move on to the advantages of the dual piston pumps. First of all, dual piston pumps offer high pressure capability. This is because the pump uses two pistons and it can generate and withstand much higher pressures compared to single piston pumps. And this also makes it ideal for demanding industrial or hydraulic system where strong force is required. Next, higher discharge rate. Dual piston pumps provide a higher discharge rate, with two pistons working in alternating cycles. The pump can deliver a larger volume of fluid per cycle, and this improves the overall output of the systems and increases efficiency. Next, another important advantage is the smoother and more consistent flow. While one piston is taking in liquid, the other piston is pushing fluid out, and this overlap reduces pulsation and creates a more stable flow, which is crucial in process that cannot tolerate fluctuations. And next, dual piston pumps also offer better efficiency because the flow is more stable in the dual piston pumps, and the system experiences less energy loss. And this leads to improved volumetric and mechanical efficiency, making the pump more cost effective in long-term operation. And last but not least, these pumps are excellent for continuous operation because they are smooth, steady low and high pressure capability make them suitable for applications that require a reliable and uninterrupted supply of fluid, especially at high pressure. We move on to the next, which is the disadvantages of dual piston pumps. First of all, dual piston pumps have a more complex design. This is because they contain more moving parts than single piston pumps. The overall design and operation become more complicated, and this can make troubleshooting and system integration more challenging. Next, they come with a higher initial cost. Since dual piston pumps include more components, the manufacturing and installation costs are higher than the single piston pumps, and this can be a significant factor for projects with limited budgets. And usually a big company will use the dual piston pumps because the cost of the maintenance and also the installation. Next, another drawback is the increased maintenance requirements. More pistons, seals and valves mean more parts that can wear out. As a result, the pump needs more frequent servicing to ensure it can operate properly and avoids breakdowns. Next, dual piston pumps also tend to have a larger size and weight. Because of their dual cylinder structure, they are bulkier and can take up more space in the system, and this can become an issue in compact installation or mobile applications. And last but not least, we have a sensitivity to fluid quality. The dual piston pumps are really sensitive to fluid quality. If the liquid contains solid particles or contaminated, it can cause internal damage and accelerate wear. This means filtration and fluid cleanliness need to be maintained carefully. Okay, that's all.